Hi students, today we are going to solve the reversing a linked list problem. Let's look at the problem statement first. The problem statement says we are given head of a singly linked list. We have to reverse the list and return the reversed list. So it's a singly linked list. So the constraints that are given are the number of nodes in the list is 0 to 5000. That means the list can be empty. So there are some constraints on the value of the node as well. Okay. So let's look at some example. Let's say sorry. Let's say the input is 1, 2, 3, 4, 5. Then when you reverse it, it will become 5, 4, 3, 2, 1. If the input is 1, 2, when you reverse it, it would be 2, 1. Okay. And now if the list is empty, then the output will also be empty. Okay. So first let's look at a recursive solution first. So we are going to look at a recursive solution first. So to come up with a recursive solution, we need to look at the possibility of a recursion. Let's say we are given a list like this. Okay. If you have to divide into sub problems, let's say by some way you reverse the next node of the list. Okay, that means you reversed this part of the list, which is it becomes 5, 4, okay, 3 and 2. Okay, now your 1 is still pointing to 2. Okay, so once you reverse only this much part of the list, this is how your list looks like. So the adjustments that you will have to make for it for 2 to point to 1 is the next of 1, which is 2 currently, should point to 1, which means we are basically reversing this arrow. Okay, instead of 1 pointing to 2, we have to make 2 point to 1. Okay, and 1 should point to null, which means it's the end of the list. So these are the 2 pointer adjustments we can do. So the recursion is, so if you are at nth node, okay, you call reverse n minus 1 and then you adjust the pointers. Adjust pointers to make the entire list reverse, which means the first node's pointer which is pointing to the second node, you have to swap it. You have to make the second node's pointer point to the first one. So that is the only adjustment we have to do. And for a recursive implementation, we also need base condition here, right? So we have two base conditions here. One is when the list is empty. When the list is empty, you just return the empty list. So based on the given constraints, we know that list can be empty. So we have to take care of that case. So the other is when list has only one element in it. In this case, when you reverse it, it's the same element. So you return the same list. So these two are the base cases. Then on the n minus 1th node, which means the current node dot next, we will call reverse, and on the return new head, we will make the pointer adjustments. That's how we will get our reverse list. So let's look at a code for this. Code for this is pretty simple actually. Okay. So first what we have to do, let's write the base conditions first. We are given head of the linked list. So linked list definition is given here by LeetCode. We don't have to define it. So a list node is defined which has value and next. It's a singly linked list, so there is no previous pointer. Okay, and some helper constructor methods are also given. Okay, so our base cases are if the linked list is empty, which is if the head is null, or if the linked list has only one element, which means head dot next is null. Okay, in these two cases, what do? There is nothing to do. We just return the head. Okay, otherwise, what do? List node new head equal to, we reverse the n minus 1 of linked list, which is reverse list head dot next. Okay, we are reversing the second half of the next part of the current head. Okay, and we have to we have to swap the pointers. So currently head dot next is still pointing to the second node. We have to make it point to the first node. So head dot next will give us second node. Okay, the pointer of that, which is head dot next should point to the current head. So in this point, what we are doing is 1 was pointing to 2, we are changing it to 2 to point to 1. Okay, okay, this is the change we have done here in this line. Now what we have to do, the head node, the current node, which is node number 1's next should be null, because that is the end of the list now. So end of the list next should always be null, otherwise it will become a loop. Okay, so head dot next should be null. Now once we are done, we have to return the new head. That's all. So what we did, we covered the base cases here, then we reverse the head dot next, which is n minus 1 of the linked list, and we swap the pointers for the first and second node. First node's next we made it point to null. That's all. That will give us a complete linked list, reversed linked list. Okay, so the solution is correct. Now let's look at the time complexity and space complexity as well. So time complexity wise, we are touching every element of the list. So if the list is of size n, it would be order of n. And space complexity would be, due to the recursion stack, you are calling n times, right? It would be order of n as well. Though we are not creating any extra variables, the recursion stack will give you that order of n complexity. Okay, now if you look at the problem statement, there is also a follow-up saying if you can build it both iteratively and recursively. So we have seen the recursive solution, it is very straightforward. Let's look at iterative solution as well. So in the iterative solution also, let's take the same linked list as an example. So to help us understand this better, what I'll do is think of another previous pointer here. So there is nothing, so it's just null. Okay, and the end of the list obviously has a next pointer. Okay, so at every point, reversing the linked list is nothing but changing the direction of these pointers, right? Let's say we are here. This is our current node, and so the one before it would be called previous. Okay, so what we have to do is we have to make the current node's next pointer to point to previous. Okay, current node's next pointer to point to previous, and previous current becomes the new previous. Current moves to the next node. So when we are at 1, node 1, okay, current is initially at 1. Current is at 1. So what we will do is we will make current dot next to point to previous. So okay, and we have to also advance the current to 2. Okay, so the previous will also become current. So it is just reassigning of variables. So previous will become your new current. Current will move forward. Okay, so these two variables are basically moving together, and in the process you are creating these next connections as well. Current dot next will move to previous. Okay, so in the first iteration it is like this. In the next iteration, this current will become previous, and this will be your new current. Okay, now in the next iteration, this will become previous, and this will become your new current. So while you are moving, in the process you are changing the direction of the pointers as well. Okay, so let's look at the code for this as well. Okay, so I cleared off that code. So for this, we need a previous pointer. Previous pointer initially, like we imagined, is null. And we need a current pointer. Current pointer is basically the current head of the list. So what do we do? While current is not equal to null, okay, we have to now change the pointers. So look at this carefully because there is too much of pointer manipulation. So since we are manipulating current dot next, let's take it to a temporary variable first. Okay, and we have to make current dot next as previous. That is how we will reverse the list, right? And previous will become the current. So the next, for the next iteration, the current node would be a previous node. Okay, and you also have to move the current to the next node. Current dot next is already changed here in line 17, but we have taken a backup of the node. So the current becomes the temp variable which we have taken. Okay, at the end of all this, our previous will have the reverse node's head, which is why we'll have to return the previous. Let's run this and see. Okay, so if you look at the time complexity of this, here also we are traversing all the nodes, so time complexity is still same, but there is no recursion. We just took two variables, that's all. There is no extra memory that is created, so the space complexity in this solution is order of 1. Okay, hope you enjoyed this problem. Thanks for joining in today. Keep practicing and improving your problem solving skills. See you in the next video.